I need a countdown. Can you do the fingers? No, you can't do it. Welcome, everybody, again to our third talk. Kevin Quin will be speaking on astrophotography processing. Kevin's a member of NOVAC. He's a very accomplished astrophoto processor. And one of his two highlights, one is he shows people that it's possible to do astrophotography from light polluted skies and shows us all up. Everybody who claims, well, I can't get to a dark site, he proves you don't have to get to a dark site. He also shows that you can make beautiful pictures with post-processing. And he's very willing to share his knowledge with others. He's organized a series of photo processing sessions at the Providence Community Center in Fairfax, near the Vienna Metro, about once every other month, roughly on Saturdays, and all are welcome to attend. He sends out notices on the NOVAC mail list. So if you get the bug here, you can follow up with more of his presentations, and he invites other experienced astrophotographers to share their experience. So with that, I'll turn it over to Kevin. Thank you.
Thanks. So each time I do one of these presentations, I call it "You Suck at Astrophotography," and so do I. Because the truth is, I have no technical background in any of this stuff. I have no idea really what I'm doing, other than by devoting a ridiculous amount of time to it, have figured out, okay, so hey, this worked, so write that down, keep track of that. If you have any questions, I'll try and answer them, but I don't guarantee that I can. So this is the 7th one of these that I've done, I guess starting with one that I did way back at the Mid-Atlantic Astrophotography Workshop back 5 or 6 years ago now. What we're going to talk about here today is image processing. One of the challenges that you find with image processing, and I'm sorry I'm going to violate my agreement with you, Euro, but I'm coming back. One of the challenges I find with image processing is that people, whenever you talk to somebody, like on a web forum, and you say, okay, I got my data, I stood outside in the snow, in with the snow on the ground, with the mosquitoes, whatever, and I've got my images now. The answer that you tend to get, what do I do? The answer that you tend to get back is, well, your image will be absolute crap unless you read this 350-page book and dive into every single tab of a program that took somebody 10 years to write and takes you an hour just to download from the web. And you don't have to do that. So this is a great book if you want to use PixInsight. It's 350 pages and walks you through it and really explains to you what to do. But don't feel like I can't do anything until I read the 350-page book. There are plenty of things that you can do. So what I'm going to try and do is I'm going to walk you through actually processing an image. I have a little bit of a presentation to walk through at first, give you just a little bit of background on what we're going to do and why, some of the structure so that you have a sense of what's happening while we're going through this. But not really intended to be a presentation. It's intended to be, I'm going to sit down at the laptop, and hopefully some of you folks downloaded the data that I put up on the web, and you can walk along and process it yourself, or you can process it later and try and follow the same steps. And as we go through, if you guys have any questions about what I'm doing, please feel free to ask, because I will be asking some of you guys questions now and then too. One of the things that I had to do for this is I've been processing in PixInsight for the last couple of years. Before that, I processed in Deepsky Stacker and Photoshop. And so one of the things that I had to do to get ready for this presentation, because I want to show you how to do it with freeware. PixInsight is not freeware, as anybody who has gone to download it knows. But Deepsky Stacker and Photoshop, well, Photoshop CS2 is wave your hands. I don't really know what it is. I know that it's available on the web. And Adobe knows that it's available on the web too. But I'm going to show you how to use these programs that are fairly straightforward, and I'm also going to show you how to do exactly the same thing in PixInsight. PixInsight is complicated, but I think from my perspective, I think the reason a lot of us feel that PixInsight is complicated is because a lot of us have already used Photoshop. And Photoshop is complicated. Photoshop is complicated, let me tell you. But if you've already used it, well, then it doesn't seem anywhere near as hard as PixInsight. Anyway, so I'm going to walk you through how to do exactly the same set of data in Deepsky Stacker and Photoshop, and how to do the same sort of things in PixInsight. We're going to start with Deepsky Stacker, since that is free. As I was saying earlier, I can get pretty pictures every once in a while, but it's not from any expertise that I have. I just have spent a lot of time trying to figure out how to do these things. As we were talking about a little bit earlier, Alan said that I can have demonstrated that deep sky imaging is possible through light polluted skies. That's because I can use narrowband filters. I just stand in awe of all of you guys who go out into the back of Beyond every time you're taking pictures and set up all your gear, take your pictures, break it all down, and go back home and process it. My telescope is permanently set up in my backyard. And it's right outside the door. I control it with a computer from my nice, warm, air-conditioned house. This is the original Skybox, and you can see that all it is a C11 on a fork mount sitting inside this little roll-off doghouse. So that was Skybox until May. And right now, that is Skybox 1.0, post-chainsaw. I got a new mount, finally, after many, many years of using the fork mount. I finally upgraded my mount. The upgraded mount won't fit in the doghouse, so that means new observatory. If I was going to do new observatory, I said, if I'm going to go all this trouble again, I may as well do it the right way. So this is Skybox 2 as of yesterday morning. You can see I've got one pier up already. I'm going to put 2 piers in here because I do both deep sky and planetary imaging, and may as well be permanently set up for both rather than just one. So one pier is already set up. The second pier will go in as soon as the machine shop gives me a few little changes. And then hopefully by August or so, I will have a roof built on it. OK, so we're going to go into actual processing now. There are 5 steps to processing. At least that's the way I think of them. I mean, you could conclude that there are 100 steps to processing if you really want to think about it that way. But to keep things organized, I think of these 5 different steps. Calibration, which is where you put together all the biases and darks and flats that you hopefully took the same time that you were taking your light images. Stacking, which is when you put all of that together. Linear processing, which is you take the image that comes out of the stacking process, which has all your images together, and you start doing some refinements to it. Stretching, which is where we take our initial image, which if any of you have looked at an image that comes straight out of stacking, it's basically black and has a few stars in it. So stretching is where you start to bring out your galaxy, your nebula, whatever's there that you're trying to pick up on. And then finishing, sharpen, remove some noise, change colors, things like that. I have left those 5 steps written on the blackboard over here, just in case anybody wants to refer to them as we're going through. What I'm going to do from here is kind of flip back and forth between the PowerPoint presentation and the 2 or 3 pieces of software that I'm going to use to process this data. As I mentioned, this data was posted online last week, and I'm not going to take it down. It's still up there. So anytime you want, feel free to download it and mess with it. This presentation also will be online. At the end of the presentation, I'll put up links that show you both where the presentation is and where you can get to the data again. So I pressed the button of doom, obviously.
Press that button again.
It was the right arrow.
The right one was just blank. Oh.
That's the
Oh,
button
you're
I've been
pressing
pressing. It's just a left arrow and a right arrow. I pressed the right arrow. OK, good. So the magic touch. So as I said, we're going to talk about 3 different pieces of software. The software that I used to use until about 2 years ago, Calibrate and Stack in Deepsky Stacker. Processing, meaning linear processing, stretching, and finishing in Photoshop. About 2 years ago, I moved to PixInsight. And so to get ready for this presentation, I have been refreshing my memory over how to use Deepsky Stacker and Photoshop to do the things that I now do in PixInsight. So Photoshop CS2 is out there. You can also get Creative Cloud from Adobe now, which I think is $10 a month. And the thing I'll tell you about CS2 is it works with Windows 8 and Windows 10, and that's pretty much it. It's glitchy, which we may very well run into because I have a Windows 8 machine here that I'm going to, or Windows 10 machine that I'm going to use to demonstrate it. So up through Windows 7, it ran fine for me. But to me, if you're just getting into this now, pay the $10 a month to use Creative Cloud. If you get deep into astrophotography, $10 a month will be the least of your expenses, believe me. But on the other hand, if you have not done any image processing work before and you don't really use Photoshop, I would just go straight to PixInsight. So PixInsight is, you pay them in euros, and I think it's like $280. So it's a fair investment. But if you're confident that this is a hobby that you want to stay in and you actually want to process, rather than learning these and then later on learning PixInsight, just learn PixInsight. That's what I would do. But if you're just getting started, you're not sure how deep you're going to dive into this, feel free to use Deepsky Stacker and Photoshop CS2. I'll show you links for where you get Deepsky Stacker and PixInsight at the end of the presentation. Oh, so first thing I want to do is I want to follow, how many of you sat in on John Soiko's presentation this morning? Okay, so one of the things that John said was calibrate. And the reason that you calibrate is because your images will suck if you don't. There's no guarantee that your image won't suck if you do calibrate, but it will suck less if you calibrate. So this is a calibrated image. All I've done with this is I stacked it and I stretched it a little bit, and I haven't done anything else to it. So you see it actually does have a dust spot up here that, like I said, your images can suck even if you do properly calibrate, as this one is. I have no idea why the dust spot is there. Fix it later on in Photoshop. But that's a calibrated image. If you don't calibrate, you get that. So I used to live in a world where I thought, okay, I can use flats. That's all I really need to use. I don't need to do the whole 9 yards. I don't need to use bias and darks. Wrong. If you don't use bias, instead of getting dark halos and dark vignetting and a dark dust donut, you get a bright dust donut and bright vignetting and bright halos. So yeah, you do want to calibrate. And I know that it seems like a pain at first, but once you get the hang of it, calibration is something that you just start off or you do during the night, and it really does not cost you anything. It really doesn't take that much time. Particularly for those of you who have a cooled camera, you can do the biases and the darks anytime you want. So the only thing that you need to do each night you take pictures is to take flats. So yeah, it's worth going to the trouble of doing that. So we're going to walk through each of these steps one at a time. We'll be flipping back and forth between the processing and showing you how this works. I'm just going to walk a little bit through what actually happens here with calibration. So calibration will take out that vignetting that you saw around the outside of the frame. It'll take care of those dust spots for you if something doesn't go wrong, as did in my globular cluster image. It will help your flats work correctly. That's what bias does. It'll take care of bright and dark pixels. That's what your flat and your darks do. And at the end, you'll get an image that doesn't have all those obvious defects that you saw earlier. So this is actually supposed to say what do flats do rather than what does calibration do. So what flats will do, you saw in the image that we were looking at on M12, you see how it's dark around the outside edges here? This is called vignetting. It's just, you can actually see this in a camera, a normal daytime camera sometimes. If you're shooting a bright sky and you look closely into the corners, you may see some darkness in those corners. But in a telescope, long focal length, really pronounced. Some of you I know have been able to get away without flats. Stop it. Don't do that. Because you will find that once you start using flats, it does make other things easier. So yeah, use the flats. But that's what flats does. Takes care of this dust donut if you did your flat the right way, and it will take care of this vignetting. So here's the example. Another thing it'll do, I use an off-axis guider, which uses a pick-off mirror, and that creates a shadow on the chip. So in addition to the normal vignetting, you see this nice dark shadow across the chip. Dust donuts like this, if you have any dust, particularly on your sensor, you will get spots like this on your final image. So the flats will take care of all this. Basically what you're doing is you're taking a picture of a very bright object, and the computer then understands this is what gray means to me, and it will work to fix that. However, like I said earlier, you will need bias frames for that, because if you don't use bias frames and you try to just use flats, instead of you'll solve this dark vignetting and the dark donut, but you'll get bright vignetting and bright donuts instead. So that's what the bias will do for you. The other thing that you should keep in mind about calibration is it fixes those defects like that, but the thing is your sensor is defective straight out of the box. Because what we'd like to think is that every pixel on a sensor is identical. It responds to light the same way, it responds to heat the same way, because your sensors do pick up heat, and it responds to being read out. In other words, having the electrons transferred from your chip to your computer responds in the same way. But in fact, each pixel responds in a slightly different way. So they are non-uniform, and these calibration frames, in addition to taking care of the obvious things like vignetting and dust donuts, they will take care of that. What you'll find if you don't use it, this should be a perfectly gray image. And instead, you can see that because the pixels are non-uniform, that's what an image will actually look like if you don't calibrate it. But once you do the calibration, well, here's what it'll actually look like in an image. So what I've done here is I've zoomed up really, really close on 2 stars. Here's a calibrated image. You can see it has a nice smooth background. Here's an uncalibrated image. You can see all this speckling in the background. So that can be from non-uniformity, non-uniform response to light, non-uniform response to heat, non-uniform response to being read out. But once your computer knows how your chip behaves, it can take care of all that for you. So calibrate. So we're gonna start with calibration. We'll walk through that first. What I'm gonna do is I'm gonna start with Deepsky Stacker. So Deepsky Stacker is freeware. It's been around for at least 10 years now. It's a good program. It's fairly straightforward to use, and it's what I used for, probably 5, 6, 7 years before moving to PixInsight. And it's a pretty easy program to use. What I'm going to do is I'm going to use the Veil Nebula data that I posted online. What I posted was just the 3 stacked images. But what I'm going to do is I'm going to go back to a little bit of the raw data just to show you how to use the program. So the information that I posted online, the 3 images that I posted were post-stacking. But we're going to go back to the beginning to show you how to calibrate and how to stack. So what I've got is I've got 5 bias frames, I've got 5 dark frames, I've got 5 flat frames, and I think I've got 5 light frames. Now, I use a lot more frames than that to process, but just to demonstrate to you how the programs work, I'm just using a small number of frames. So let's start with Deepsky Stacker. So this is the main window in Deepsky Stacker, and really it's the only window in Deepsky Stacker. It's a fairly simple program, which is the beauty of it. All you do to get started here for your calibration is to open each one of your files. So I just have a single bias. I misspoke. I don't actually have 5 bias frames. I've actually already combined these into a master bias. But I'll show you how that process works. So there's the bias frame. Whoop, sorry, that's actually not what I want to do because I just loaded it the wrong way. All right, so let's walk through these. I'm going to load my light frames first. So these are the pictures that you went out and you struggled to get through the mosquitoes and the in between the lightning storms. Now I'm going to load the darks. If you have a camera with regulated cooling, you took these at home one night when it was raining outside. I'll load the flats. Those are something that you should at least have taken in the field the night you were shooting the lights. And I will load my bias frames. Now, as I said, I just have a single bias frame here because it's already been merged into one. I think I started from 250 bias frames because having a regulated camera, I just sat one night and had to take a whole ton of bias frames. Yeah.
For a rank beginner, what is a bias and what is a flat?
Yeah, okay, so let me back up for a minute. This is what I was going through a little bit earlier. In fact, let me go back just for a minute here to this. So let's start with the one that's easiest to understand, a flat. What you're doing with a flat is you're taking a picture of a bright object. And the idea is you're conveying to the computer is this is what gray means to my camera and my whole imaging system, not just your camera. So chip, camera, electronics, your telescope, any kind of field flattener you use between the telescope and the camera. This is what gray should mean. And what you're telling the computer is that should be a uniform gray picture. Computer looks at it and realizes that is not a uniform gray picture, so I need to deal with that in some way or another. But the way you take a flat is, did John go into this? Basically, the way you take a flat is to point it at a fairly bright object that is uniformly illuminated. And so that's what you're trying to tell the computer is this should be uniformly illuminated. And when the computer looks at it and realizes that's not, then it knows how to fix your other images. So it applies those same fixes to those other images. A dark frame does the same thing, except that instead of non-uniformity with respect to light, it's non-uniformity with respect to heat. The sensor in your camera picks up ambient heat inside your camera, and your camera generates a ton of heat. So those pixels that you think are just recording the starlight are also recording the random infrared energy that your camera is generating and you don't want it to, but usually records it in the same way. Last thing is that a good explanation for darks? And again, you're telling the computer the same thing. You take a picture of what is supposed to be a black object. In other words, you put the lens cap on. And when the computer looks at it and says, that's not uniformly black, I see spots in it, then it knows how to fix your other images the same way. So final thing is bias. Your camera is, each of these pixels gets read out by the electronics behind the chip, but each of them responds in a different way to being read out. We'd like to think that they all respond exactly the same way. If I've got 100 electrons in my pixel, 100 electrons gets dumped down the wire. And again, this is where we run into the challenges for the limitations of my technical knowledge. It doesn't work that way. So each of these pixels gets read out in a somewhat different way. And so the way you create a bias frame is you take a frame that's 0 duration, has a lens cap on, and therefore should be black. But when the computer looks at it, says, again, I see specks through this thing, and then knows how to treat your frames for this read noise that's generated. There's actually 2 other things that bias does, which gets into why they help your flats. More technical knowledge than anyone needs to know at this level. But the suffice it to say that when I showed that example, you saw the totally uncalibrated frame had dark vignetting around it. And if you try to calibrate just with flats, it will just transfer it to become bright vignetting instead. That's why you need to have the bias frames. But again, bias frames, even if you have a DSLR that doesn't have regulated cooling, chances are you can just put it in a dark closet at your house, take 250 0 duration exposures, and that's all the biases that you will need for like a year. Do that once a year and you're set. Yeah, Mark?
Bias then, is that a function of just the hardware itself, or do you have to do start to
Right.
You're taking as fast of a photo that the camera can take, and the optics, your telescope is capped or your lens is capped, and you're just getting basically, okay, give me as short of an exposure as possible, and I want to see what your viewpoint is.
Right.
Oh, it'd be one thousandth or even faster.
Yeah, whatever the fastest shutter time is for your camera, that's what you want to set for a bias frame. No, dark current is that's what your dark frame does. So the dark frame, if you're shooting like a 5-minute picture of the stars, your dark frames should each be 5 minutes, because that tells how much heat is generated in the camera in 5 minutes. But a bias is as short as you can shoot it. John? It is. It's the chip and the electronics behind it. Yeah, it's the way the electrons are moved from the chip into your computer. John?
One way of thinking of it is the bias and dark together, it's a little complicated, the bias and dark together tell the computer what zero should look like.
Yeah,
And
that's right.
flat frame, if it were bright, but it's not really up there, tells the computer what one should look like. You're giving the same brightness value to every pixel, and you do something to the numbers to make them come out that way. So for the flat, you're applying a multiplicative adjustment, and for the dark, bias, you're doing an additive subtractive. So you're getting zero right, and you're getting the full scale right. And then what it did on the light frames should be correct, if you treat the light frames the same way.
Right. Right. Before I show you how to use Deepsky Stacker to actually do this calibration, I'm going to talk about stacking first. The reason I'm going to do that is because both of these programs that I use for calibration and stacking, they basically do it as one process. Certainly Deepsky Stacker does, and you can kind of do it that way in PixInsight as well. So I just want to walk through what stacking actually means. So we talked about calibration, flats, darks, biases. Now you've got your light frames too, which are the pictures that you took of the stars while you were outside. What stacking does is it looks at modern programs. When they stack, they look for the stars in your image. And they figure out where the stars are in each image, and then they figure out how to line them up from there. And they will make minor adjustments into each of those images until you get the images are all lined up so that they can be stacked on top of each other. What stacking means is that each pixel, once the frames are aligned so that the stars all line up with each other, the computer looks at each of those pixels and adds up the value of all the pixels in all the images that you took. Then it will average them out. And so it'll give you one final image out of it. So you can feed 100 images into it. If you took 100 5-minute exposures of the stars, you feed those 100 images into the computer, you get one image out of it. And each of those pixels in the final image is the average of each of those pixels in the images that went into it. And the result is, the reason we do that is, if you've ever seen a picture, even from a regular digital camera that you've taken in a dark room, you can see how grainy it is in the background, especially if you zoom in on it. The reason that we stack these images is because that, in effect, reduces the graininess. We call it noise, but you can see it in a plain old ordinary image too. So this is a single image that I took of the Wizard Nebula, which is this background image here, by the way. It's not calibrated or anything. So you see these bright hot pixels in it that it hasn't been calibrated out. That's a single image. That's a stack of 20 images. So I tried as much as I could to stretch these in exactly the same way so that you could see the background. But you can see how the detail really starts to pop out. And the noise really starts to go down. So you can see, even behind these bright hot pixels, you can probably see how grainy this image is. But it's certainly very dark, whatever else. But when you stack them up, you get that. So that's the purpose of stacking, is to reduce that noise, that graininess that you see in the background. So let's go ahead. We're going to calibrate and we're going to stack. And we'll walk through first how to do this with Deepsky Stacker.
Those little white dots, was that just
Those are hot pixels. Your dark frames will take care of those. I'm going to show you what hot pixels look like here in just a few minutes, because PixInsight has a great utility that lets you see just how bad hot pixels are if you don't fix them. So here in Deepsky Stacker, we already went through, we loaded all of our frames. We've got our light frames here. You can see that it actually calls them light frames. It understands what your frames are for the most part. We've got our dark frames. I loaded my flats. I loaded my master bias because like I said before, I've already stacked up that bias frame. What you can do, it's always good to preview these frames. So this window up here, you can brighten it by dragging this slider a little bit. This window up here will give you an idea of what you're looking at. And so it's always a good idea to preview your frames. You just click on each one, and it'll show you what the frame looks like. And if you see bad ones, take them out of your stack. Don't include the bad ones. But it's always a good idea to flip through them, because you'll always have some bad ones that you'll be happy to take out of the stack. So what I do is I go through, you're going to go on and go through and hit check all. What that means is it puts a check mark here. All of these frames will be used to stack this image now. Before I start stacking it, I just save the file list in case I want to use it later on. That way I've got it saved and I don't have to reload everything. Pick one of these frames that you want it to line up on. So you're using that as the reference frame. And so what the computer will do will say, I'm going to try and line everything up on that frame there. Right click on it, use as reference frame. Then the next step is to register. So you've got all your calibration frames, all the frames you want to stack. Now you're registering them. And I'm just going to go ahead, what this is going to do is it's going to look at each one of those and start to figure out how to line them up. It's always a good idea to look at this advanced tab. When you hit register, you get this dialog that pops up. It's always good to look in the advanced tab and have it take a look at the number of stars that it's seeing. Because sometimes you'll run this and you'll find that it's not seeing anywhere near enough stars. But 100 stars is plenty. That's how many stars it's been able to pull out of those frames. So I'll go ahead and I'll let it register these. And you see what it's doing right now. It's going through each of the flats, and it's going to create, it's stacking up all those flat frames and creating a master flat. Then it goes through all, if I had multiple bias frames, it would go through the bias frames, create a master bias. It's stacking up the darks and creating a master dark frame. And then it goes back through the light frames, and it figures out how to line them all up on each other. So now it's gone through and it's registered all these, and I can show you where it puts these. Whoop, sorry, not there. If we look in the data, you'll see that so these are the raw images that I put into it. So these are the light images. These are the raw images that I put into it. As I went through, Deepsky Stacker creates a calibrated version of each one of these things. So it stores these for you. If you want to go back to them later, it's created them and saved them. The next step is to compute the offsets. This also goes into the step of figuring out how to line these things all up. So now it knows. See how it says these differences here? It knows that it has to nudge this one 1.76 pixels in one axis, 1.35 in the other, has to rotate it a little, and now it knows how to stack all these up. So from here, and I'm ready to stack now, I just click on Stack Checked Pictures, and I want to look at how I'm going to stack up. So I look at these stacking parameters. Deepsky Stacker will give you advice in this box here. It'll tell you how to set some of these settings, but if you want to go in individually, the stacking parameters are all in there. So what I do is, at least in this one, I'm going to average. If you have, the best thing to do is to use what they call these kappa sigma clipping settings. They will tend to knock out some of those hot pixels, some of those really bright pixels. This is something that you will just gradually learn how to use. The setting that I use is usually auto-adaptive weighted average, but I don't actually have enough pictures here. That would be great if I had 30, 40, 50, but for this demonstration I only have 5, so I'm just going to run it on average. I think these other settings, the defaults that it goes to, are usually fine. Output, you just tell it where you want to put the output frame. So remember what it's going to do is it's going to stack up all your images, and it's going to give you one integrated picture now. So I'm just going to put it back in. Yes, that's the right place. And so what it's doing now is it's taking the calibrated images that it's created, and it's stacking them all up, and it's going to feed you out one image at the end here. Is this what? No, this is the actual data that I used. I mean, this is. Yeah, we will at the end. Oh, I'm sorry. When you say a model, what do you mean?
The one you're working on now.
Yeah.
Is it monochrome?
Oh, is it monochrome? I'm sorry. I thought you were asking if it was just model, like mock-up data. No, this is 3 separate channels. I'm only demonstrating how to stack one here. I'll show you later on when we're using Photoshop. I'll show you how to put them all together. Yes. Yeah, so if you guys are shooting with DSLRs, like most people will, just run them through Deepsky Stacker. It will figure that out, how to debayer on its own, right? Yeah, I know that in earlier versions of Deepsky Stacker many years ago, sometimes you had to tell it how to do the debayering. In other words, tell it what color means to your camera. But I think currently Deepsky Stacker will handle all that, so you don't need to mess with any of that stuff. So this is the stacked image here. It will automatically save a copy of this in case you mess up, but always good to save a copy where you want it. So I just called it 16-bit output, and I've already saved it in my files. The one thing that I should say here is that when you're stacking with Deepsky Stacker and you feed in all those raw calibration frames, it will create masters for you. So it'll create a master flat, it'll create a master bias, it'll create a master dark. So if you took other images that night and you want to apply the same flats, or the same bias, or the same darks, you don't have to recreate this process. Just go back into the folder where you had everything saved and use the masters in the future. So that's how this works in Deepsky Stacker. That's the calibration and stacking process. I'm going to show how to do the same thing in PixInsight, which is, like I said, it's a little bit more complicated, but I think once you start using it, you realize it's not as challenging as it might otherwise be. So I'm just going to start from the beginning here. How's that?
What caused you to switch over to PixInsight?
PixInsight has some advantages over Deepsky Stacker and Photoshop. The biggest thing is dealing with light pollution gradients in the background. So the one thing that I notice is that I shoot through a lot of light pollution, but a bigger issue is that I might shoot the same target over 15 nights. Because I'm shooting between trees, I can only shoot a target for maybe 3 hours a night. So particularly for narrowband imaging, I got to get a lot of time on that target. And the target's going to be over here, it's going to be over there. The moon was there one night. Hey, the moon was over there. Another night, there was no moon. One night, that super bright outdoor display screen in the Mosaic district was flashing all night long. Another night, they didn't use it at all. So I've got a lot of different junk in the background. And PixInsight has a tool that I'll show you here that will remove that stuff. It's a very convenient tool. You can do that in Photoshop, and it is way harder. I could spend hours with each image trying to do what I can do in a minute with Deepsky Stacker. So for me, that was the big thing, but there are other conveniences that it has as well. Like James, wasn't it you that was saying the other day that you find it actually stacks more accurately?
It creates your master bias and darks better.
Right.
If you do all your stretching together side by side,
Right. So Deepsky Stacker will make those masters for you, but PixInsight is purpose-built from the ground up for astrophotography. And the algorithms that it uses are more advanced than what you're going to find in Deepsky Stacker. Yeah, that's true, although you will see that you can actually get a 32-bit image into Photoshop. It's just you can't do much with it in Photoshop. So that's the other advantage of PixInsight. When your stacking programs run, they create a 32-bit image for you, whereas your camera usually created a 16-bit image. And doing your stretching in particular in 32 bits, you can stretch harder without getting posterization out of it. So that's another big advantage of PixInsight. So I'm going to walk through PixInsight. I'm going to recreate the calibration and stacking process that we did here. But I'll try and walk through it and do exactly the same things that we did, just using different tools. So PixInsight uses processes and it uses scripts. We're going to walk through some of each of those. Those are the tools that it uses to process your image. The first thing we're going to do is we're going to look at our data and throw out the bad ones. So we use a process called blink. And what that does is I load in I've already loaded these in. These are my light frames. So this is the Veil Nebula, this is the brightest chunk of the eastern half of the Veil Nebula that I took from my backyard last summer. And you can see each picture is slightly different from the others. And you can use this process. You can just flip through the blink process. If you see a bad image, take it out. Don't use it. This is just a process that lets you preview these things. One thing I do want to show you, though, I'm going to zoom in on this. So in fact, I'll make it even a little bigger than that. So you see those bright hot pixels in the background there? All those sparkly things? This is a single image. I'm going to run through 5 images and just play it on a loop. So what you can see here is the stars move because each picture, was slightly off from the others. But what you can also see is that the hot pixels and the graininess that's in the background from read noise, from the non-uniformity of your sensor, that doesn't move. The stars may be in a different place. They may fall, that starlight may fall in a different pixel on your chip, but the bad things associated with your chip, that's constant. The advantage of it being constant is you can fix it. So that's just a way to display what the calibration process will do here. There is another advantage that you have in PixInsight, and another reason that I started using it is that it will do a much better job on hot pixels. It has an advanced tool called Cosmetic Correction that will go in and actually remove those hot pixels. I can give you a quick look at how that works. Well, let me just walk through the process step by step. So the first thing that I do with PixInsight is I create my master bias and my master dark files. And again, what that does, it took all your biases and stacked them up and made one. Took all your darks, stacked it up and made one. And these are called masters. There's a reason we're doing that first. This script, batch preprocessing, is the way you'll do almost all your calibration and stacking, at least as a beginner, in PixInsight. So we'll go in and we'll add in all of our files here. This is my bias. I use something called a super bias in PixInsight. I add in my flats. or sorry, these are my darks. PixInsight actually knows what these are. You can see these were darks, and it filed them correctly for me, whereas the bias, it filed for me also. Because this is a master bias, I actually have to check this box in PixInsight and tell it what I'm doing, so it knows that that's a master and not just a single individual bias frame. So there are my darks. I'll add in my flats. And now, last thing, I'll add in my lights. Oop, actually, I'm sorry. At this phase, I'm not gonna do my lights, because all I'm doing here is I'm creating a master dark and a master bias. So I'm not even gonna use my, I'm not doing my flats here. What we're doing at this point is we're gonna create, since I've already got a master bias, I guess all we're gonna create is a master dark here. And the reason we're doing this is to do cosmetic correction. It's a much more advanced way to get rid of your hot pixels than is available in Deepsky Stacker. So I tell it where I want to put this. I'm just going to put it in this PixInsight output folder. That tells it what folder to put the output into. I click run, and PixInsight comes back and tells me, wait, bad things. You're not using flats. You're not using lights. You don't have very many darks. And I know, because all I'm doing here is I'm stacking up my bias and my dark frames. So just go ahead and let that run in the background. And what it does, just like Deepsky Stacker, it takes all those biases, creates a master out of them, takes all those darks, and creates a master out of them. Now, the reason we're doing this right now is because we want to use this master dark for a reason. I'm going to go ahead and close the batch preprocessing and close the blink. So this is the third step that I usually apply, which is this process called cosmetic correction. And what this does is all those hot pixels that you saw in the background as I was running that little video of the 5 frames, this is going to help get rid of those. So I'm going to just open up one of my light frames, the data that I took that night. I'm going to stretch it a little bit. We'll talk about how to do that stretching process later. I'm going to zoom in on it a little bit so you can see what we're actually looking at. So you can see that there are hot pixels in the background there. That's what the really bright pixels are, the individual pixels. Because you can see they're not stars. They're just like these individual bright hot pixels. What cosmetic correction does is tells the computer how to get rid of those hot pixels. This is a tool that you really can't recreate in Deepsky Stacker or Photoshop. I used to use a third program to do this before I started working with PixInsight. So in PixInsight, I'm going to pull up my master dark frame, which I have saved. Yeah, that's the one I'm going to use. So what we're doing here is we're going to remove the hot pixels. So I click this Enable Hot Pixels Threshold. And to get rid of the hot pixels, I just grab this slider here that says Sigma next to it. And as I move up far enough, oh wait, I got to set a preview. This little circle here will show a preview of what's actually happening. Yeah, okay, you can see they're gone now. Let me zoom in a little here. All right, so let me reset it back down. So you see all the hot pixels in here, all these bright pixels? As I tell the computer get more aggressive at removing them, you can start seeing that they're starting to disappear. And you can go too far and make the picture blurry. But what I usually find is right about there is the level that I want to use. So you can see not every single hot pixel disappears, but you got rid of a lot more hot pixels than you were going to kill off with Deepsky Stacker. So what you do is, this is called a process in PixInsight. I just save it by grabbing that little triangle there and dropping it here. And I'm just going to give it a name, Cosmetic Correction, CosCore. So now what this is going to do is when I stack my pictures, in addition to applying the flats and the biases and the darks the same way Deepsky Stacker did, it's going to look at this cosmetic correction thing, and it's going to fix those hot pixels in addition. So let's just close the preview here. And so now we go back to this main script. This is the script that you use, batch pre-processing. This is how you stack, this is how you calibrate and stack in PixInsight. So once again, I'm going to load in my darks. And PixInsight knows what these are because your camera marks them. Deepsky Stacker, you have to tell it. But PixInsight knows what these frames are. Like, it knows that those were darks and not flats. It knows which ones were lights. I load in my bias frame. I load in my flats. Got everything. Now I load in my lights. So I don't. Normally, so what you're doing here, because you're calibrating and stacking, I'm doing stacking all in one process here. I think you could, like if you shot everything one night and you only have one set of flats, and you have one set of darks, one set of biases, if you shot everything in one night, I think you can calibrate all at once, but I'm going to include stacking in here, so that you would have to do separately.
And in narrow band, you can get phenomenon.
Actually, let me back up for just 1 minute. Howard, I take it back. I'm wrong. You can actually put all your frames for a single night into a single process here. So normally I don't use this batch preprocessing. I don't use it to stack. I only use it to calibrate. PixInsight wants you to go the extra 9 yards and do some extra work in stacking, but I'm showing this for beginners.
Yeah.
And with batch preprocessing, yeah, you can throw everything into your batch preprocessing setup, and it will run them all at once.
I'm trying to do that on the phone with it. I did all 3 narrow bands last night.
Yeah,
So I can demo it today and get it.
yeah. As long as you look at it in PixInsight and it says, oh yeah, I realize that that's an S2 frame, I realize that that's an HA frame, as long as it knows what the frames are, it will apply the correct flats to each of those frames. So yeah, you can dump everything into the batch preprocessing script. And while the PixInsight guys will tell you, oh, don't stack in batch preprocessing, it's fine. It's fine, you can do it. There's extra stuff that you can do if you go that extra 9 yards, but for people just getting started, do it all in batch preprocessing. It's a simpler way to do it. So what I've done here is I've taken all my images that I took that night, whether they're flats or darks or biases or the actual images that I took of my target, and I've dumped them all into this batch preprocessing script. PixInsight knows what each one is. I mean, it knows this is a flat. It knows that's a master bias. It knows this one is a light frame, and it knows how to put them all together. This is the brains of these programs that I don't understand.
You don't have to label when it starts with flats.
Correct. Yeah. So one caveat on that, a DSLR may not correctly label them as darks, flats, bias. It depends on what program is running your DSLR to capture. But for a cooled camera running through dedicated astro imaging software, when it captures those pictures, it puts a tag on those pictures usually that will tell PixInsight how to read it and know what it is.
So if we're beginner and we're using the camera ourselves.
Check and make sure. So here in PixInsight, you see how it's got these separate tabs in the batch preprocessing window here? Go back and make sure. So for example, I just missed something here. This is a master bias, so I actually need to check this and tell PixInsight that's a master. I'm not exactly sure why PixInsight doesn't realize it's a master, because it created that master a few months ago for me. And I'm not sure why it didn't flag it, so it can automatically be read, but you do have to flag it. But to answer your question, yeah, just go through each of these and make sure that your darks are in the right place, make sure your flats are in the right place, make sure your lights are in the right place. If not, you can move them around. So I've loaded everything up. Last step I wanted to tell you here that we were talking about before was cosmetic correction. So remember, I created this little process over here to take care of hot pixels in my frame. But I got to tell batch preprocessing when it's running, I got to tell it to use that. So here, under this cosmetic correction box, I click apply, and I tell it the name of that icon. I've called it CosCore. So I just tell it, apply CosCore as you're stacking these images. So I've got everything set. You want to make sure that you've clicked apply here, otherwise it'll just calibrate. You want it to integrate the images, which that's the fancy term for stacking is integration. So click apply. Let me check my script here and make sure I'm in the right place. Yeah, so just click apply. Two last things you want to do is, just like in Deepsky Stacker, you want to tell it what to use as a registration frame. So I'm just going to pick the first one of my lights. What you're telling is put all the stars on top of, at the same place that this light frame has the stars. And you also want to tell it where to send the output. And I just have, I created a folder called PI output here. So we're all set. I'm going to click the run button here. And PixInsight gives me a whole bunch of warnings. It tries to make, especially the batch preprocessing script, it tries to be idiot-proof for you. So it's telling me that it doesn't like the way I'm stacking my dark frames because I don't have enough. It doesn't like the way I'm stacking my flats also because I don't have enough. Same thing for the lights. So I'm only using 5 of each of these since it's a demonstration. I'd be using a lot more and I wouldn't be getting these warnings. But I'm going to say, yeah, just go ahead and stack anyway. What it's also telling me now is, this is what we were getting to. Sorry, this is what I was getting to with Howard. It does not want me to stack with batch preprocessing, but for beginners, fine, stack with batch preprocessing. It's okay. It will work. And I'll just hit continue, and it's going to run in the background here. So what it's doing here is, same thing with Deepsky Stacker. It's going through and it's creating masters where I didn't have masters before. And then it'll apply each of those calibration masters to each light frame, and it'll create a corrected light frame for me. So it's calibrating the light frames for me with all those calibration frames. It's registering the light frames to that registration frame that I picked, making sure that they're all lined up the right way. And then, because I told it to stack, it'll go ahead and make a single output frame for me. One of the advantages of doing it this way is, just like with Deepsky Stacker, it will create those masters for you. You can go back and manipulate them later. It will also create calibrated frames for you before they're stacked. It'll create calibrated and registered frames before they're stacked. So if you want to get down into the weeds of the process and change something in the future, you don't have to recreate the wheel. You don't have to go through this entire stacking process again. And calibration, it will save them for you in case you want to go back and manipulate them later. Okay, so it's finished here. I'm just going to show you where it's put these. Well, I've probably like overstacked things at this point because I ran this before. But what I told it to use this folder PI output, and you see what it's done is it's created a folder of all my calibrated images. And if I open that up, I've got calibrated flats, because it had to apply the bias to the flats. I've got calibrated lights. So it took each of the light frames and it applied the bias, the flat, and the dark to those and created a calibrated frame for each one of my lights. But then it also has this folder called Cosmetized. That goes to Cosmetic Correction. So what it did here, it has a calibrated, that's what the C means. CC means cosmetized. So it took each one of those calibrated frames, and then it did the dark pixel correction that Cosmetic Correction is. So here I've got, in this output, I've got all my calibrated frames. But then what it did is it took the calibrated frames and it aligned them all, and it created registered frames for me. So you see these ones say C for calibrated, CC for cosmetized, and R for registered. So this is the last stage before stacking. But then because I told it to stack, it went through and it created, in this masters folder, it created an integrated light. That's what the light is right there. So Howard, what you were talking about was, I can show you what it does here. In the registered frame, you would find one for HA, one for S2, and one for O3. And it'll put them in separate folders for you. Same thing when you go, when you go into your master folder, you'll see it created a dark master, it created a flat master, but it also created an HA master. You'll see an S2 master, it'll call it light filter, I guess depending on what process you use to name these things. But for me, it calls it light filter HA, light filter S2, light filter O3. So I know that's my integrated master frame for further processing. So that is how the first two steps, calibration and stacking, work in these two different programs. I showed you how Deepsky Stacker works. You can see that in PixInsight, the batch preprocessing script is different, but I wouldn't really call it any harder. I mean, there was that extra step, the cosmetic correction to take care of hot pixels, but that's something that Deepsky Stacker can't do for you. So it's an advantage that PixInsight gives you. But to me, up until this stage, I wouldn't really say that PixInsight is any harder. It's just, it has more options, but you don't have to use any of them. That's the beauty of this batch preprocessing script. So we've calibrated and stacked in two different ways. Since I've got PixInsight open here, I'm going to go on to the next three steps: linear processing, stretching, and finishing in PixInsight. But then we'll go back and I'll show you how to do the same thing in Photoshop. So in PixInsight, I've done the first step here. Sure, we can exit that. I usually do these. Howard, you'll know this. The guys who have used PixInsight a little bit, I use separate workspaces to do these different steps. So I do calibration and stacking in one workspace. For you guys who don't use PixInsight, a workspace is like a desktop. PixInsight gives you a different work area, so you don't have a whole lot of clutter. So I saved my cosmetic correction here. I would have also saved my batch preprocessing script up here in case I wanted to go back and redo some of this work. But I'm going to go into the next workspace, which I call linear processing. So you can see it's a clean workspace, a clean desktop to start over on. So first step that I usually do is I do denoise. How many, just so I know, how many people here use PixInsight now?
Use it or have it?
Both, if you have it. So if you guys have PixInsight, once you start using it, you would want to do noise reduction at this stage. There's a process called Murray denoise, and if you all came last year to the Alcon convention, I was kind of laughing at Murray denoise and saying there's no way that is a beginner thing to do. And I still feel that way. It's not a beginner thing to do. But once you start using PixInsight, I really recommend that you look into Murray denoise. So noise reduction deals with the graininess that we all saw in the background of these pictures. Noise reduction will turn that from a grainy picture into a nice smooth picture. It'll also screw up your picture if you overdo it. Murray denoise, you actually teach PixInsight about the characteristics of your camera. And once PixInsight knows the characteristics of your camera, it can apply noise reduction in a much better way. So like, Bob, I don't do any other noise reduction after that point. But the thing about Murray denoise is you have to do it first. As soon as you crop or you extract background or anything like that, you're done. You can't use Murray denoise there. because it's looking at the characteristics of flats and darks and biases that you feed it. It reads those, and then it says, I know how to do noise reduction on this camera. So look into that when you get a chance. Won't walk through that now. I'm just going to show you some of the basics of how this process works, though. So I'm going to open my 3 stacked images. I've saved them in a different place here. I've called them integrated masters. And so PixInsight likes to use a format called XISF, which is fine. That's just a format for the image. And I'm going to open those files. So I have one, I took these through 3 different filters. One I took through a sulfur 2 filter, one I took through an oxygen 3 filter, and one I took through a hydrogen alpha filter. And they all have different problems with them. I'm going to show you where we go from here. So the first thing we're going to do is this step of linear processing. What I usually do at this place is I do some cropping because they've got some bad edges in them that don't quite match up. And then I'm going to combine them into one color image. You guys who have DSLRs, you don't have to do that color combine stage, but these other things, they'll match up for you. So for one thing I want to show you here is this is a preview that PixInsight gives you as a special bonus. But the actual image, like let's look at my hydrogen alpha image. My actual hydrogen alpha image at this point doesn't look like that. It looks like that. So there's this tool called screen transfer function. I usually call it up just by clicking this button here. What it does is it kind of gives you a quick preview of what your image is going to look like at the end, but it hasn't actually done anything to your image. This is just a preview. And this is something that you can't really do with Photoshop. There's ways, but it's not anywhere near as convenient as this. So what I'm going to do is I'm getting ready to merge these. But the thing is that they all have kind of different backgrounds. They have different darkness levels. And what I need to do is tell PixInsight how to put these together so I don't wind up with a picture that's like, all red or all blue at this phase. So I go through this step called linear fit. That's another process. And what linear fit does is it just says, you need to pick one of these 3 to be the reference. I'm just going to pick the hydrogen alpha frame to be the reference. That's fine. And what it does is it says, hey, look at this S2 frame and try and make it match up to the hydrogen alpha frame. Look at the O3 frame, try and make it match up to the hydrogen alpha frame. And the way you do that is you just drag this triangle onto the S2 image. This is not the world's fastest laptop, by the way. PixInsight can be kind of demanding. And you see it change the background a little bit. So I'll apply that preview, the screen transfer function again. I'm going to also do this linear fit to the O3. It's, again, making the O3 match up to the hydrogen alpha image. And this just makes it less likely that you'll wind up with an image that's horrid when you put it together. And again, I'll apply that background. And again, I'm going to save this up at the top here in case I ever want to go back. I can just double click it, and I've got that whole process that I just did in case I want to go back and do it again.
What this is doing then is it's basically making sure that all 3 of these pictures have the same background.
Yeah,
or
that's right.
the same brightness.
Yeah, roughly.
Maximum brightness.
This is a rough tool. You can mess with this later on, and you almost certainly will in dealing with color. But this is a rough tool to kind of try and get you to this point.
Does PixInsight have any documentation on how they actually do that?
Oh, good heavens. Oh, yes, see all these windows over here? You can click on these to your heart's delight, and it will tell you everything you ever wanted to know about how these processes work. Yeah, these guys are image processing geeks, and they love it. And I never read that stuff because I have no clue what 99% of it means, but they do. And so you can learn whatever you want from those tips.
Have people ever used this like a non-abstract
Not that I know of. You could. Yeah, you could. So what I'm going to do now is I'm going to take these together and I'm going to put together a color image. And what you're doing is you call up another process called LRGB combination. And I've only got red, green, and blue here. So what I do is I tell it I want my S2 to be red. I want my HA image to be green. I want my O3 image to be blue. And then I just apply this, and it puts those three black and white images together into a color image. And again, you can see it's black, right? So we'll preview it here with the STF. And that's what it looks like. Now, if I had done that without the linear fit step that we did before, it would probably be all green in the background there. But this came out, reasonably well.
So if you were using straight RGB filters, it would have come out looking, that's kind of the Hubble palette right there, right?
Yeah, that is the Hubble palette that I just
Straight
matched to.
RGB would have come out looking completely different then, right?
Yes, absolutely. Yeah, very different thing. So I'm just going to save this as my color image. And we'll just
So this
put it in here.
It's a lot easier to do this in PixInsight than in Photoshop then. I've heard horror stories of trying to get the Hubble palette and everything working in Photoshop.
I'll show you how to do that. If we have time, I will show you how to do that. If not, anybody who wants, I will feel free to reconvene elsewhere at a time that the powers that be choose and walk you through the rest of this process in Photoshop, okay? For right now, I'm just going to push ahead in PixInsight. We'll get as far as we can into a Photoshop version of this processing as well. But what we've done is we've combined this into a color image. Now, I'm just going to crop the bad edges off because you can see like there's a bright yellow edge here that I really don't like. So I just call up another process that's called dynamic crop. Whoop. Sorry, messed that one up. And do it again. So I just draw a boundary around it, and what it'll do is it'll just crop to that boundary. So it just cropped off that bad edge there, so I don't have to deal with it in the future. Another process that you'll find here is dynamic background extraction that we were talking about earlier to get rid of some of these ugly color gradients that you can wind up with. I'm not going to show that now, but again, that's a great tool in PixInsight that you cannot recreate. Well, you cannot recreate without hours of labor in Photoshop. Actually, you know what? I'm going to show this really quick because I think it will actually help with this. So there's this process called dynamic background extraction. I've got to close that first. So there's this process called dynamic background extraction, and what it does is it looks at all the colors in the background here. You kind of set it up to cast a net over this image. Where are my DBE levels? 0.7. So when I click this generate, what it does is it creates these little sample points over the background. And I'm going to get rid of some of them because I don't like them. They're on my nebula, and I don't want that. What I'm trying to do is I'm telling PixInsight, this is what the background of this image is. Everything that you see here is just background, empty space, and it should all look gray. It shouldn't look yellow or green or blue. It should all look gray. And if you do it right, and you get these sampling points in the right place, it does a great job, and it will remove a lot of ugly color casts that you otherwise would wind up with. Yeah, there's our rain. So I'm going to show you really quick what it's going to do here. So what it's doing is it's going through the image, and it's figuring out what the background is. and what the background, what the problems are with the background, and it creates this background model, which I'll enhance this a little for you. So you can see that's pretty ugly. That should be a nice, smooth, uniform color, and it's not. And what PixInsight will do will be to subtract this mess from your image to leave you something that hopefully is not nearly as messy. So now I can see it's a little bit smoother in the background here. I have less yellow and less blue in the corners, and that's the image that I want. Another thing I would do here is I would try and do some color correction and color balancing. I might try and do some noise reduction. I'm not going to do that here because I want to try and leave some time to show you how to do these things in Photoshop as well. But again, if you guys want to talk about noise reduction in PixInsight, or you want to talk about color calibration in PixInsight, feel free to ask me later and I'll show you how to do that. But for right now, I'm just going to save this image. I think this is good enough for what we need. And we'll move on to the next step in PixInsight.
Kevin, is there anything like a slider to adjust the balance on an image like that?
Yeah, well, what it wants you to do is apply these tools called background neutralization and color calibration. You can do it manually. I've never tried it. Much easier to use the built-in tools. But yeah, you could definitely do that if you wanted to. All right, so I'm going to take this image. I'm going to go over into a nice clean workspace, open it up again. There it is. I gave it an obscure name, image 04DBE, but okay, that's fine. We know what it is. And by the way, the reason I'm using this image, my images don't usually look like this. You can guess that I picked one of my best images to use for this workshop. There are plenty of images on the cutting room floor as well. So we've got this image, but remember, this is just a preview. The image actually looks like that right now. So what we've moved into is the stretching phase. We just did linear processing where we combined the colors and got rid of some of the ugly background gradients. Now we're going to do the stretching phase, and we're going to change it from a black image into an image that somebody might actually want to see. An image that you could show your spouse, and they would say, now I get it. If you get them to say that, please write down what it was you said before they said, now I know why you're spending thousands of dollars on this. Make sure you write that down and tell us what it was, okay? Okay, so what we're going to do is we're going to apply two tools here called histogram stretching and curves, or histogram transformation and curves transformation. You will see exactly the same tools in Photoshop, just under different names. In Photoshop, they're called levels and curves. Here, they're called histogram transformation and curves transformation. But they do, as near as I can tell, they do exactly the same thing. So in PixInsight, I like to do histogram transformation first. I'm going to set up a little preview. And what we do is we just grab this. We grab this gray point here. What you can see, if you can actually look closely enough, is this is kind of a display of the data that you've got. This is how many white pixels you have. You can see you have 0. This is how many, say, half gray pixels you have. You can say you almost have 0. This is how many really, really almost black pixels you have. You can see that's where all of your data is, right there. So what we're going to do is we're going to take that really, really dark data and we're going to brighten it up by stretching it. And to stretch, you grab this midpoint here and you drag over like this. See how the image is starting to brighten up now? Now you're starting to see some of that information in the background. And I'm just going to drag it and drop it. That's how you apply something in Photoshop, or sorry, in PixInsight. So I did one stretch, but I can definitely do more than that, because you can see most of the data is still all concentrated over here in the black. So I'm going to stretch it one more time here. Let's go, all the way up there, right? So again, we'll drag and drop that. And that stretched it up. But you can see now it's starting to brighten up the background, and I really don't like that. So what I'm going to do next is I'm going to apply another stretch. There's your preview. And this time what I'm going to do is I'm going to drag this left point, which is the dark background, and this will darken it up. You see, let's darken it up to...
I noticed you haven't touched the white point yet.
No, never touch the white point with this process. There may be reasons to do that, but I've never come across one anyway. So I think that's pretty good for the background that I want. It may have actually been a little too far, but that's okay for a demonstration. And again, if you drag this little triangle and you drop it onto the desktop background, it'll save it for you, so you can go back and try and recreate some of these steps later on. This is how you save your work. So that was the histogram transformation. It's the equivalent of levels in Photoshop. I'm going to go on and do a curves transformation, which is just called curves in Photoshop. And I will try and brighten this up a little bit more. So there's a preview. The way you do this is you grab it with your mouse and start pulling it up like this. Now you can see I'm brightening my background a little bit more than I might like to. So I'm going to start darkening it up a little. Maybe that was a little more than I wanted. That's pretty good, like that. And again, drag and drop it. So now I've basically stretched the way I want it to, but here's one thing that you'll notice is it's really kind of greenish, sort of, and that's not really a color that most people find very pleasing. So what I'm going to do is, final touch that I'll apply here in PixInsight is I'm going to go to Process in this tool called, where is it, SCNR. And you guys who do narrowband images, when you wind up at this last step and you've got this green image, this is how you fix it. So SCNR, I'm going to set the color that I want to fix as green, because this image actually isn't bad, but a lot of these narrowband images will be just masses of ugly green all through them. I just want to adjust this a little bit, so you're going to attack the green here. Usually just use the default settings, drag it and drop it.
What does that stand for?
SCNR, what are you challenging me? Why are you asking me these questions? I don't know. Something chromatic noise reduction. There you are. So I'm going to show you before. See how kind of, too many steps before. Okay, so there's kind of when it was this yellowish green color. After, it gets that nice gold color. You can manipulate these colors any way you want. There are a million different steps that you could apply, but that's the basics for how you would process in PixInsight. A lot of steps that you could do from there. But what I want to do is I want to give you a quick run through of how to do the same thing in Photoshop while we have a chance here. So we'll open up Photoshop. Yeah, I know. That's why I want to try and just do this, do a quick comparison of how the process works in Photoshop. So I just open up, what's that? You mean later though, right? Okay, that's fine. So like we said, if anybody has any questions, we'll try and talk about this more later, and please feel free to come up to me and ask me questions as well. So I've got my integrated masters that Deepsky Stacker put together for me, and I'm just going to open them here in Photoshop. They're actually 32-bit images. The first step in Photoshop is you need to convert to 16-bit, because Photoshop just does not work with 32-bit images. So it's just this initial step. You also see Photoshop really does not like working with Windows 10. At least CS2 doesn't. So I'm just converting these all down to 16-bit images so I can work with them some more. Okay, last one. Okay, so now they're all converted to 16-bit images, and I can put them together. The way you do this is you go over to the Layers panel in Photoshop, and I open up the Channels tab here, and that shows, whoops, sorry, I got to convert one of these images first. I have to turn this into a color image. Right now it's a black and white image. At least in Photoshop's head, it's a black and white image. I'm just going to tell it, hey, Photoshop, this is actually a color image. And so now it says RGB. Photoshop thinks it's color, whereas these ones it still thinks are monochrome images. So I start with this color image, and I go to the Layers palette. and I open up the channels. I've got one for red, one for green, one for blue. And what I'm going to do is I'm going to get rid of those. The red one, I'm going to make S2 the red one. So I just copy that. And then I go back into this image. And I just paste it in. For the green one, I'm going to use the hydrogen alpha. So just copy that. Oops. So it just copied in as, and I didn't do that quite right. So I just made sulfur 2 the red, and now I'm going to copy the blue image, or the O3 image, and I'm going to use that as blue. And now I'm going to stretch these for you, and you're going to see, this is the merged image now. You're going to see once I stretch these, you're going to see how green they are. So just like with PixInsight, we're going to apply curves, which I usually get from here in this layers palette. We're going to apply some curves and start stretching it up so it brightens. And do another one here. So you can see it's brightening up. The background is really getting ugly. So we'll do some levels here as well. And you can see that one thing that I didn't do here is I haven't done color calibration to try and match these things up. This is something that's much easier to do in PixInsight, but you can do it here with this curves function. And what I do is, for each color, I try and make these histograms line up. So red, I'm going to leave alone. Green, I'm going to pull down a little. Blue, it looks like I could leave alone. That looks good like that. So now it's a little bit, the background is a little bit better, I'm a little happier with that. Let's apply some more curves to brighten it up a little bit more. And now I'm going to apply levels, and I'm just going to darken up that background a little. Now, see how green it is? This is the typical problem that you run into with narrowband images, that you get this nice green color out of them. I'm just going to brighten this up a tiny bit more. There we are. That's good enough for now. So there is a way to fix this in Photoshop. Because few beginners are doing narrowband images, I'm not going to walk through how to do that. I'm going to leave it here. But I can show anybody who's interested how to achieve the same thing in Photoshop that we achieved in PixInsight and not have this nice green veil nebula, but to get the more blue, orange, yellow color that you're probably more used to. But I just want to stop and ask if anybody has any questions, and we can talk again about doing some more processing a little bit later on. Any questions for now, though?
What you just did included both stretching and finishing.
Yeah, so I have kind of, in Photoshop, I've kind of compressed those three processes. The linear processing, which was where I put the colors together. The stretching, which is what I did with curves and with levels. And finishing, I haven't actually done any of that in Photoshop. But that would be to do this color change. That's what I would think of as finishing. But I haven't done any of that here in this demonstration. Yes? Does PixInsight work with Apple? I believe the answer is yes. I think they even have a Unix version of it, or a Linux version of it.
Kevin, I looked at the website. It said the primary development is Red Hat 7 series, towards OS X Lion, and Windows all the way up through 10.
Okay, so yes, yeah. Like I said, these guys are gearheads, and processing is what they do on any platform you can imagine. I bet they do most of their processing in Linux.
What camera are you currently using?
This is a cooled CCD camera from Starlight Express, and it gets me about a 22 by 28 minute field of view with an 11-inch SCT. Anything else? Okay. Thanks for having me. And if you, again, questions, I'm here.
Kevin,
That's probably a good
It'll clear up,
idea.
It'll clear up. And we had the same thing, we had a downpour yesterday, we had a downpour the day before.
Well,
And then it cleared.
yeah.
We can do it
Why
in
don't
the evening.
yeah? Why don't we plan to do that? And then if it clears out, people when they're ready to go, they will clear out.
And certainly